Hi, I don't know most of you on this thread, though I feel like I know Bob because he reviewed one of our papers last year, and also I read his book last summer. But my name's Calais, and I wanted to tell you a little bit about this desmos tool. Here is an orbit for one of the double star systems that we tested. I think this was one of the class 2s. And this is the 03337 plus 5752 is the name. You can look up the fit, and it looks like this. And so we requested the raw data from the Washington Double Star Catalog. We got these numbers and plotted them, and they didn't look like this. They looked like a cloud. And so what was going on is that the data was, some of it was not rotated properly. You assume counterclockwise from celestial north, but it wasn't all done that way. So when you put the data along with the given orbital elements that are published together, you get these enormous residuals, and it looks like this plot here. You can click on this plot. It's a link in the spreadsheet that I sent. It'll open up in Desmos, the original graph, and then you can tell which points have the big residuals and correct their rotation one by one to improve the calculated value of r squared. So for example, watch what happens when I flip the signs of x and y on this 1985 point. Just gonna get rid of that and get rid of that. You see how it snapped into position right on the ellipse. So when the ellipse was fit, the correct rotations must have been used, but in the data, they're incorrect currently. So you can see I'm going to put them back. That's a negative and that's a negative. That makes it really useful because you can tell which ones had that happen. If you take the published orbital parameters and the data set, you can see visually which ones are wrong like that. I'm just going to show again how that snaps back into place because it's so cool. So check that out. Right on the ellipse. So in the spreadsheet, here's the one that was fit with the data flipped when they were figured out which ones had that happen one by one. And the r squared is much better, 0.99 instead of the negative 1.93. And the power of the tool is that it shows you that, whoops, wrong one. Right here in the calculations. So here is, let's see, r squared's down at the bottom somewhere, but you can see that right now it's very bad, and if one by one I correct the rotations of those points, it automatically updates and becomes better. So that's, I think, one of the most useful things about this tool is to allow you to zero in on data that has these sorts of problems. But also, here's something else. So one more point to make about this tool, and that is this blind test that Richard gave Hagen for the paper. And Hagen's solution is in green, Dr. Hartkopf's I think is in purple. And you can see that the difference is the weightings. Dr. Hartkopf seems kind of more constrained to catch this purple, these points near the bottom left. And then Hagen's is more generally applicable to the data set without weightings. And the question I would ask all of you is whether it makes sense to try and incorporate the weightings into a tool such as this. It's a visual tool, so it's helpful for getting orbits that fit generally well to the data. It's not meant to be a final orbital solution. The problem that inspired the creation of this tool was that you need a good initial guess at the parameters before feeding them into a more sophisticated gradient descent algorithm, or Hagen does this differential correction stuff now, and he's even working on a new algorithm to make the final solution. But that's not what Desmos is for, really. It only does 50 points, by copy paste, and I think it's really great for getting that good initial guess because you can get them visually, where then you would need to weight the data and put it into a more sophisticated algorithm that can handle all of the points in order to make the final solution. So I sort of question whether trying to find a way to put weightings into desmos is ultimately something that would be useful, but you can judge for yourself. In any case, have a wonderful day, and it's sort of nice to virtually meet you all. Bye.